Alright guys, here we are for lesson number 4. You guys have 4 minutes and you guys have 3 questions. The bottom 2 are F equals MA questions, so if you were unable to see lesson 3 yesterday, that's fine. You should still be able to figure it out based on the units. Just set it up with Newton's second law, F equals MA. Alright, and you got 4 minutes, go! Alright folks, put your pens down, give me your attention up front. We're going to start going over the pre-class Question number 1 is that question again. I keep asking it to you because you need to really know your laws and you need to know them in order. So if you're looking at your notes and using like previous day's notes over and over again to do your pre-classes, again, remember that you have to have it memorized by test time. You're not going to have a little cheat sheet to look off of. Alright, so again, make sure you have them memorized, but the acronym I asked you to stand for, and what does it stand for? Again, if you don't like the acronym, that's fine. Just know the laws in order, and I'm happy. Alright, so the acronym I gave you guys was Little Isaac's Fictional Monsters Are Actually Real. It stands for Law of Inertia, F equals ma, and Action Reaction. Question number 2, what is the mass of a ball that has 100 newtons of force acting on it to accelerate it to 4 meters per second squared? Again, this is a straight up F equals ma Newton's second law problem, which if you missed yesterday's lesson for whatever reason the video didn't load, or if you're in a class that did get to see it, it's the same exact lesson, there's just a difference which we'll talk about later. So anyway, first we're going to picture our situation. Here we have a ball. It's being pushed or moved with a constant force of 100 newtons, and it's forcing it to accelerate at 4 meters per second squared. So now we're going to pull out our givens. We have 100 newtons. Again, newtons tells us that it's force. It also says the word force in the problem. We have an acceleration of 4 meters per second squared. Again, you can tell by the units, but it does also say the word accelerate on there. And we are looking for mass. So when I pull out those givens, I have m equals question mark, a equals 4, and f equals 100. Next, we're going to be looking for our equation. So we select our equation. Our equation is obviously f equals ma. And then we do step 4, which is what do you have and what do you need, which for a simple one-step math problem is kind of a useless step. So I usually skip over it, but for when you guys get into harder math problems, this is the most important step that you have to do. Step 5, we're going to plug and chug in the numbers that we have. So we have f equals ma. Again, they're color-coded so you can follow along with me. So we have 100 is equal to m times 4, or 4 times m, whatever makes you happier. So if we want to get m by itself, right now it's being multiplied by 4. Therefore, we need to divide 4 on both sides. So if you take 100 and you divide it by 4, just think about money. All right, 100 divided by 4 is a quarter, 25. All right, so we have a mass of 25 kg, all right, kilograms. Question number 3. Ziani is on planet Genius, where she weighs 50 newtons. She knows that she has a mass of 60 kilograms. What is the gravitational pull of the planet she is on? So this is what we covered yesterday in Lesson 3. If you guys missed the video, it's not a big deal. It is the same exact thing as question number 2. The difference is you just really have to look at those units. So we have to picture our situation first. Here we have Ziani chilling on her planet. Woot woot. Alright, next we're going to be writing down our givens, and again you can tell just by the units if you weren't sure what weight is. Weight is a type of force. You can tell because it's in newtons. So we have a force of 50 newtons, we have a mass of 60 kilograms. Gravitational pull is going to give us an acceleration is what gravitational pull is. So if we select our equation, it's going to be F equals ma. Alright, and again this step's not really big for a one-step problem, and then we're going to plug and chug. We have 50 is equal to 60 times a. Divide 60 on both sides, and we're left with a is equal to 0.833 meters per second squared. So the gravitational pull on planet Genius is 0.833 meters per second squared, which is pretty weak. So if you went on that planet and you tried to jump, you would jump really high. So there's very little gravity pulling you down. Alright, so that's it for our challenge today, so hopefully you were good with those questions. So just some quick announcements. So some of my students have told me that people were worried about homeworks being really long. Homework 1 shouldn't have been a problem for anybody. It's really quick. Homework 2 is a lot of questions. It's really easy, but it's a lot of questions. Homework 3 I could see being a little bit long. Again, remember there's a few things that I told you guys before. If you guys are doing really well on tests and you're skipping homework problems because you're like, alright, this is redundant, I've done this problem 100 times, that's fine. Give the homework a quick read over. Make sure you're doing all the problems that you need to do in order to practice and be confident. Right? If you're handing me no homeworks and you're failing my tests, then I have a problem with it. If you're getting all hundreds on my tests and you're getting really good scores and you're not doing as much homework, I'm fine with that. Alright, it's up to you. You need to do what you need to do in order to pass the class. For right now, just continue to do the homework sheets I give you. I can't really do anything else because I already printed all the homework sheets. They're all done already. So I can't like go in and change them or make them less or anything like that. So for now, just do your best you can with them. Maybe when I get back, I'll give you guys a makeup day to catch up if you guys are really stressed out. So we'll talk about that. Lesson 3. So yesterday some of the classes were able to see lesson 3 because somebody downloaded the video and played it that way. And that's fine. If you didn't get to see lesson 3, you didn't really miss much. I'm going to cover it pretty much in one slide on the next slide. So today I am going to go through with lesson 4. If you really want to see lesson 3, you can hop on Schoology. I updated the link and added a link that should work this time. So check that out. Lesson 3 will be on Schoology, and I'll talk about that in a little bit. If you have questions, concerns, or comments, again, shoot me an email on Schoology. A lot of students have been shooting me messages. That's great. I love it. So whether it's feedback, you have questions, concerns, comments, whatever you want, feel free to shoot me a question. I'll help you guys out. And then we'll do a little bit of review today just to make up for people who weren't able to see the video yesterday in terms of Lesson 3. So first things first, I'm going to give you guys a few seconds to write down your access code. So if you're in period 1, I want you to write down your access code, period 3, period 9, period 10, period 11, etc., etc. I have been posting these videos every day on Schoology, so that way if you guys went home and you wanted to see the video again or access something on there, you could do that. So I have the codes up there, so please write down your code. That way you can join the Schoology class and then see those assignments and get to those links if you guys are curious. Again, otherwise you can just message me on Schoology and I can try and send you an email. It is kind of hard for me to check my Schoology email while I'm watching the twins and my toddler, so it might take me a little bit of time, but I will get to it by the end of the day, or at like 3 or 4 in the morning, which is generally when I'm doing all these videos. So anyway, please take your time, write that down, and give you guys about another 10 seconds to write down your code. So, just a quick review of what we did yesterday. Yesterday we talked about the differences between mass and weight, and then we did a bunch of practice problems that had to do with Newton's second law, F equals ma. So first, mass is how much stuff is in something. It's how much matter is in an object, right? So if you take a balloon, there's not much matter in a balloon, right? There's a few air particles in there. They're bouncing around so much that they give the balloon its shape. If we're talking about a bowling ball has a lot of mass in there. Therefore, there are a lot of atoms in there. We say that's a very massive object. Weight is how much gravitational acceleration pulls down on a mass. That's what weight is. So mass is how much stuff you have in an object. Weight is how much does gravity pull that mass down towards the center of whatever planet you're on. Alright, so because of that, mass is a property of an object. It does not change, whereas weight will change based on where you are. So let me go back and backtrack there. So mass is a property of an object, just like if you have a pen and your pen is blue. If you go to Mars, the pen is still blue. It doesn't like start writing red. If you have a pen and it's 2 inches big and you go to Mars, it's still 2 inches big. It doesn't get smaller. Mass is a property. If there are 100 atoms in an object, and again that's a ridiculously small number, but just to give you an idea, if there are 100 atoms in an object, when you go to the moon, there's still 100 atoms in the object. It doesn't change. Mass doesn't change no matter where you go. Weight, however, is a condition that is based on the size of the planet and where you're located. So gravitational acceleration is based on where you are. So your weight on the first floor of a building actually changes from the second floor to the third floor to if you're in an airplane or if you're in space or if you're on the moon. Your weight changes wherever you go. Generally, does your weight change enough from the first floor to the second floor that you can tell a difference? No. Mathematically speaking, it's probably insignificant. But if you checked your weight on an airplane and your weight on the ground, your weight would probably be like 1 or 2 pounds different. So weight changes based on where you are. Mass never changes. No matter what planet you're on, you have the same mass. Alright, so what we learned yesterday was since weight is a type of force, right? If I jump on your face, you feel the weight of my body on your face, and that hurts. Weight is a type of force, therefore, by Newton's second law, it must be a mass, or it must have a mass and an acceleration. Therefore, weight, which we can call W, so yesterday I called it W equals mg. Today I'm going back to what I was trying to tell you guys, which is I usually write it like this, where Fg, G for gravity, and F is force, so force of gravity, which is what we call weight, is equal to mass times Ag, acceleration of gravity, which is whatever planet you're on, the acceleration of that planet, which on Earth is 9.8 meters per second squared. So if you're on Earth, this Ag is understood to be 9.8 meters per second squared. And yes, that number changes whether you're in an airplane or on the 5th floor to the 1st floor, but 9.8 is the approximate number that we give for Earth. Okay? So even if you missed yesterday, really that one slide there covers everything that we did yesterday. So you should be able to do everything else from there and study the notes that you have and be okay. Alright, so today we are going to be talking about momentum.
Don't you know who I am? I'm the Juggernaut!
Lovely lady.
I always crush my cans before I throw them away. Thank you. I wonder if he's recyclable. Now what?
Storm.
Didn't my worthless brother tell you it's no use?
Alright, so today we are going to be talking about momentum. So you'll notice that on this title page, rather than making fun of one of you and having your faces on something, I have a picture of the Juggernaut, which if you guys are familiar with like Marvel Comics or you saw the X-Men movie, you should know the Juggernaut, which I can't write the expletive that it says, but he says, don't you know who I am? I'm the Juggernaut, and then beep. But anyway, momentum is his superpower. So the whole thing with Juggernaut is once he starts moving, there's nothing that can stop him. So we're going to talk about momentum today in today's lesson. Juggernaut will kind of be my theme, so you'll see him on a lot of slides as we go through. Alright, essential question for today. How is momentum related to Newton's 3 laws of motion? And my goal is that you guys will be able to apply your knowledge of momentum in a few word problems to solve for unknown variables. And tomorrow it'll be to step that up one bit, and we're going to talk about elastic and inelastic collisions and how things are going to work out then. And that's when it gets a little bit tricky, but today should be pretty simple. Alright, so first things first, momentum. Momentum in an equation is a lowercase p. That's very important for you guys to memorize. Put a star next to it. It is not a capital P. If I see you writing a capital P, I will mark your whatever wrong, your question or whatever you're doing wrong, because a capital P means power. It doesn't mean momentum. So again, make sure it's a lowercase p. Whether or not it's capital or lowercase matters, just like when we were doing metric prefixes, a capital M is mega and a lowercase m is milli. So these letters are case sensitive, so just be very careful with that. Alright, momentum, an easier way of saying it, it is the amount of stuff that is moving and how fast it is moving. That's pretty much what momentum means. So for instance, if we have a balloon and a bowling ball moving, which one is easier to stop? Alright, so here I have my balloon, same size as this bowling ball. Both are moving towards you. Which one is easier to stop and why? Right? So if you look at this, the balloon really has a few air particles inside of it where that bowling ball is stacked. And you have to remember, just like if you're on a skateboard going 10 miles per hour, you and the skateboard are both going 10 miles per hour. If you have a hat on, your hat is also going 10 miles per hour. Everything is attached, therefore it's going the same speed. Here, if we have a balloon and that balloon has, 7 particles in it, then all 7 of those particles have to be moving the same speed that that balloon is. Same thing for the bowling ball, except now we have a lot more particles. So each one of those particles is moving the same speed. So inside the balloon we have 7 particles. Each of those 7 particles are moving forward. If you want to stop that balloon, then we have to be able to apply a force to each one of those particles to decelerate and stop each one. So again, it takes less of a force to stop 7 particles than it would to stop a whole crap ton like that are in the bowling ball. And you can think about this kind of like a fight as well, right? If you're in a fight and you have 7 miniature people like Dee Dee attacking you, that would be like the balloon scenario. It's probably easy for you to fight them all off and win, even though Dee Dee's a little crazy. So she might beat some people up in a fight. But we'll pretend Dee Dee's a normal tiny person and really weak. Alright, over here in the bowling ball, we have a lot of Dee Dees. That's a lot of Dee Dees to take on. So at some point, there'll be more Dee Dees than you can actually fight off, and at that point, you're going to get run over, right? If a car comes at you and a car hits you, you're probably not going to stop the car, because the car has a lot more momentum than you have the ability to stop the strength of a car. If a bicycle comes at you, you could probably stop a bicycle, right? You might get hurt, sprain an ankle or something, but you could probably stop a bicycle coming at you. So something with a lot of momentum has a lot of mass, a lot of speed, or both. Alright, so there's two different ways of looking at momentum. Something with a lot of momentum has a lot of mass or a lot of speed or both. So the equation for momentum, which we're going to talk about in a little bit, is mass times speed. So if it has a lot of speed, it's going to be hard to stop because you need to get it from like 60 miles per hour down to 0 instantaneously, right? So if someone throws a baseball at you at 100 miles per hour, it's going to hurt your hands because you have to stop it. It has a lot of speed, even though it doesn't have a lot of mass, it has a lot of speed. Right? If it has a lot of mass, it's hard to stop because you need to apply a force that has to stop each and every particle coming at you. Right? So, for instance, if a truck is put on neutral and it's coming down a hill, it might only be going 1 mile per hour, but it's going to take a lot of force for you to stop the truck because you have to stop each and every particle in that truck from moving 4 miles per hour. So again, either way, both of those things make an object have a lot of momentum. Either they have a lot of mass, or they have a lot of speed, or they could have both, and then you're just really screwed, right? If a truck is going 90 miles per hour and hits you, then you're just out of luck. Alright, so here are some examples of objects with momentum. A train moving at high speeds has a lot of momentum because it has a lot of mass and a lot of speed. That's why you don't want to get hit by a train. A tennis ball moving at the same speed as a train has a significantly less momentum because it has a much smaller mass. Tennis ball is pretty much filled with air, right? So even if a tennis ball is going at the same speed as a train, 60, 70 miles per hour, if a tennis ball hits you going that fast, I mean, it might give you a bruise, but it's not going to hurt you. It's not going to have that much momentum because the tennis ball itself doesn't have a lot of mass. So even though it has a lot of speed, it doesn't have a lot of mass. Alright, the academy school building you're sitting in, despite the fact that it's incredibly massive, right? There's a lot of bricks and stones, has no momentum because it's at rest. It's not moving. Therefore, you can stand there and the building's not going to hit you. It doesn't require any force to stop it. It's already stopped. It has no momentum. It's not doing anything. All right, and you'll hear this word momentum a lot, like you hear it in sports, right? As soon as, like right now, if the Eagles win a game, then they'll have good momentum going into the next game. And if they win that game, then they have positive momentum and they keep going on, and you have a better chance of winning the games if you keep winning. Whereas if you lose, you kind of have a negative momentum and you get in a slump and you keep doing worse and worse and worse. So you'll hear this word momentum throughout English vocabulary used a lot. Alright, so momentum, another way of saying it is mass in motion. All objects have a mass, so if the object is moving, it therefore by definition has momentum, mass in motion. Alright, momentum is equal to mass times velocity, so momentum is the letter P, a lowercase p, mass is a lowercase m, and velocity is a lowercase v. And velocity, for those of you guys who aren't familiar with it, is another way of saying speed. There's a big distinction between speed and velocity, but as a freshman, you don't have to worry about it. For my seniors, you already know what it is. So you'll talk about that more in 12th grade year when we get to it. Alright, so again, don't confuse a lowercase p for momentum with the capital P for power. Your cases are very important in physics. Remember, a capital M can be mega or it can be milli. That's a big difference, right? If I give you a $1,000,000, then I'm not even giving you a penny. If I give you a $1 then I'm giving you $1,000,000. That's a big difference. If you don't believe me, feel free. I'll give you $1,000,000 and you pay me back $1, and then we'll call it a day. I'll quit. You won't have any more homework. It's perfect. I'll be a millionaire. I'll be on the beach. I'm laughing and happy while you are out at $1,000,000 because you don't know the difference between upper and lower case. Yay! Alright, so momentum is equal to mass times velocity. So in terms of units, mass is kilograms, velocity is meters per second, which is speed. And another way to remember that, it's like miles per hour. Just in the scientific world, if we're using the metric system, we don't say miles, we use meters, because miles is an American measurement. And we don't use hours, we tend to use seconds as our measurement of time. Sometimes you'll see kilometers per hour when we talk about cars and things like that, objects that are going much faster. In this class, we'll be focusing on meters per second, so you can write that down on your sheet. Velocity is measured in meters per second, and acceleration is meters per second squared. So that's the difference between velocity and acceleration. Alright, so the unit for momentum is kg/m per s, so kilogram meters per second. Alright, so again, remember that because that's a big one. When you're reading a word problem, you need to know that. Alright, so up until now, here are the units that you need to know. Force is in newtons, mass is in kilograms, velocity is in meters per second, acceleration is in meters per second squared, and momentum is in kilogram meters per second. So you guys should know those. Right, momentum is a vector, which I know we haven't talked about in freshman class. My seniors do understand. Therefore, it has magnitude and direction. Therefore, you can have a negative momentum. It does not mean it's going slow. So, like when you see negative 30, I know a lot of people like to go, oh, well, on a number line, negative 30 is smaller than 0, therefore it's small. Where in physics, if we're talking about speed, negative 30 just means it's going the opposite direction. Right? So the car is just backing up. It's going in reverse as opposed to going forwards. So if you think about it that way, right, and I say which speed is faster, 30 miles per hour or negative 90 miles per hour? If you say 30 miles per hour, you're just being silly. And if you don't believe me, stand behind a car going negative 90 miles per hour and it'll run you over and you'll feel the difference greatly. It's a big difference. So direction is going to be given to you by plus or minus. Alright, so again, remember, a negative sign does not mean momentum is small. It means a direction. It means you're either going west or south. So if you think about the coordinate system, right, west is a negative x direction, south is a negative y direction. So an object with negative 9 kilogram meters per second has more momentum than an object with 8 kilogram meters per second because 9, the magnitude, is bigger than 8, the magnitude. The negative sign just tells you that they're going in opposite directions. Alright, so let's try a few of these problems out and see how we do. Alright, so question number 1 on your sheet. An object with a mass of 5 kilograms moves at a velocity of 3 meters per second. Alright, so we're going to just jump straight to step 2 here. We're going to write down our givens. Alright, we have a mass of 5 kilograms, we have a velocity of 3 meters per second, and we are looking for momentum. So we are looking for lowercase p. Alright, our equation is P equals mv, again all lowercase, and we just plug and chug. Mass times velocity will be 5 times 3, so we're going to get 5 times 3, and that'll give us 15, and our unit is kilogram meters per second. Real simple. Alright, so now let's try another one together. Alright, I'm going to give you guys about, I don't know, 10-15 seconds. Try out example number 2, and then we'll do it together. Alright, remember, you should at least be able to pull out your givens here, even if you can't solve it. Alright, so now let's try this together. So if we pull out our givens, again, notice kilogram meters per second. That is a momentum. It says it in the problem, momentum of 20 kilogram meters per second. We also have velocity is 5 meters per second. So therefore, in this case, we're looking for m. So out of p equals mv, we have p, we have v. So all we're doing is solving for m. So we have 20 is equal to m5, or 20 is equal to 5m, however you want to write it. If we want to get m by itself, we need to divide both sides by 5. And that gets us to m is equal to 4 kilograms. And again, I apologize for not writing it here, but at this step, we're dividing 5 on both sides. So 5 divided by 5 cancels out. And then on the other side, we have 20 divided by 5, and that gives you 4 kilograms. Alright, so now I want you guys to try out the problems on your sheet, and we'll go over them in a little bit. And be careful for the third one there. Alright, and even if you don't know how to do these, you should at least be able to write down your given, so your worksheet should not be blank. Alright, you should have something written down there, at least your givens and the equation. If you don't know how to do the algebra from there, I think it's pretty simple, but if you don't, that's fine. At least have your givens and equations written down. Alright, you guys got about 10 seconds left. Alright, so let's go over these. The first problem, we are given a mass and a speed. Therefore, we just have to multiply them together. 60 times 9 gives us 540 kilogram meters per second east. So you can either write the word east there, or it's implied because the number is positive. Alright, the next one, we're given a mass and a speed again. So our momentum would be 20,000, because 1,000 times 20 is 20,000 kilogram meters per second north. Again, you can write north on there, or you can imply it just by leaving the number positive. Alright, the next one is tricky. We have a 40 kilogram freshman moving south. Remember, south is a negative y direction, so technically that 2 should be a negative 2. So negative 2 times 40 gives you negative 80. So there are two ways that you can write this. You can either write it like this, 80 kilogram meters per second south, and the word south tells you that it's negative, or you can write it as negative 80 kilogram meters per second. And that's really important because tomorrow you're going to have to write these down as negatives or positives based on which direction it's going. So if it's going south, you would have to write negative 80 as opposed to writing the word out like I'm letting you do today. So just keep that in mind for tomorrow. Direction is going to be a very important thing. Alright, so here's my cute little thing for Juggernaut. I stand, therefore I have no momentum, and I am powerless, which is true. If Juggernaut's not moving, he can't hurt you. But you have the power to do your independent practice, so start knocking out these problems for me. Alright, so let's try these out. Question number 1. Object A has a mass of 4 kilograms. Object B has a mass of 14. They're both moving at 5 meters per second. Which has higher momentum? So if they're both moving at the same speed, then the object with more mass should have higher momentum. So object B should be your answer here. If you don't believe me, we can do the math out. Object A has a mass of 4 kilograms. Momentum is mass times velocity, so 4 times 5 gives you 20 kilogram meters per second is going to be your object A momentum. Object B is going to be 14 times 5, which I think gives you 70 kilogram meters per second. And 70 is obviously higher than 20. So let's try these out. So again, we're just going to pop them in, mass times velocity, so we're just multiplying these two numbers, 4 times 5, and we'll get 20. And then we have 14 times 5, and we should get 70. And therefore, you can tell that object B has more momentum than object A. Alright, so question number 2. Object A has a mass of 300 kilograms. Object B has a mass of 250 kilograms. Both of those items are at rest. Which object has more momentum? A little bit of a trick question here because I know a lot of people might want to say they have the same momentum, but the correct answer here would actually be they have no momentum. Both objects have 0 momentum. So to do this problem, I'm just going to make a cute little chart. I'm going to say object A, put all my givens for object A in one column, and I put all my givens for object B in another column. And again, you're going to multiply mass times velocity, and that'll give you P. So 300 times 0 gives you 0. 250 times 0 gives you 0. So you could say they have the same momentum because they have 0 kilogram meters per second, but correctly speaking, they both have no momentum. Alright, question number 3. Again, I filled the chart out already for you. Object A has a mass of 8 and it's moving at 2. Object B has a mass of 4 and it's moving at 4. Remember, we're multiplying these two numbers. Eight times 2 is 16, 4 times 4 is 16, therefore they have the same momentum. Alright, next question. Object has a mass of 106 kilograms. It is moving at negative 2.4 meters per second. Object B has a mass of 102 kilograms. It is moving at negative 3.6 meters per second. Which one has the higher momentum? Again, we're just multiplying those two numbers. I'll give you guys a few seconds to try it out. For object A, you guys should have an answer of a negative 254.4 kilogram meters per second. For object B, you should have negative 367.2 kilogram meters per second. And that tells you that object B does have more momentum. They're actually both going in the same direction, which might be south or it might be west. We can't really tell, but that negative sign just tells us it's going in one of those negative directions, either west or south. Alright, so now we're going to do this exit ticket, so follow along with me. At the bottom of your sheet, you'll notice that we have 2 exit ticket questions with underlines. We're going to put the numbers on those lines, so follow along with me. So for question number 1, I want you guys to write 60 kilograms, and for question number 2, I want you to write 1,000 kilograms. And I'll give you guys about a minute or so, so please solve for exit ticket 1 and exit ticket 2. If you guys finish, feel free to start working on your homework. Other than that, I'm going to give you guys about a minute. Alright, question number 1. We have 60 kilograms moving at 9 meters per second. East is also a key word there. East means it's going to be positive, so we don't have to do anything there. 9 times 60 gives you 540 kilogram meters per second. Again, don't forget your direction on there, east, or keep it positive. We have a 1,000 kilogram car moving north at 20 meters per second. Again, north is also a positive direction, so we have 20 times 1,000, and that gives you 20,000 kilogram meters per second north. Alright, and that's everything that we had to do with momentum. So hopefully that's enough to do your homework. You guys should have about 10 minutes left in class. Again, people were saying that they didn't have enough time to do homework, so use this time to work on homework 4. My expectation is that you guys have homework 4 out in front of you, and you're starting to knock out these problems. This should be enough time to actually finish homework 4, and also start working on one of your previous homeworks if you haven't finished that. Alright, so please begin doing that. Thank you, and have a great day.